Welcome viewers, in this video we'll see the details about parallel adder. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic parallel adder in digital electronics. A single full adder performs the addition of two 1-bit numbers and input carry. We know that we have full adder and half adder. Half adder add 2 bits. Full adder will add 2 bits and carry. So practically we need to add the carry from the previous digit. So 2 bits and carry is performed by full adder. But it will add only only one bit. But a parallel adder is a digital circuit capable of finding the arithmetic sum of two binary numbers that is greater than 1 bit in length by operating corresponding pairs of bit in a parallel. So full adder will add only 1 bit data, two 1-bit data and carry. If n number of bits available, more than 1 bits are available, we can go for a parallel adder. Parallelly the bits are added. First bit of first number, first bit of second number will be added. Similarly, second bit of first number, second bit of second number will be added parallelly. So that it is called a parallel adder. Right. Now we'll see the further detail. It consists of parallel adders connected in a chain where the output carry from each adder is connected to the carry input of the next higher adder, full adder in the chain. So n number of parallel adders, n number of full adders will be there. So every adder will add 2 bits. The carry also, the carry from the first adder is given to the next adder. Like that it will forward. A n-bit parallel adder requires n full adders to perform the operation. Suppose we want to perform n number of n bits, means we need n number of parallel adders. For example, if you want to find 4 bit to perform the 4-bit addition, means 4 full adders are needed. So for the 2-bit number 2 adders are needed, while for 4-bit number 4 adders are needed, and so on. So according to the number of bits, number of adders are needed. Now we will see the block diagram, a logic diagram of the parallel adder. Parallel adder normally incorporate carry look ahead logic to ensure that carry propagation between the subsequent stages of the addition does not limit addition speed. So here we are using the carry look ahead adder, so that the carry propagation delay is not much more, so it will not limit the addition speed, right? So carry look ahead means the normally carry 1 will be generated, thereby carry 2 generated, then by carry 3 generated, like that. Carry look ahead order means once the carry C1 is generated, C2, C3, C4 will be parallelly generated. That is called a carry look ahead logic. The carry look ahead logic, the separate video is available. Now we'll see the logic diagram of the parallel adder. N number, n bits, here n bits. So here this parallel adder, full adder 1, full adder 2, full adder n minus 1, full adder n. So n number of full adders are available. So A1, A2, An minus 1, An is the first number, digits of the first number. Similarly, B1, B2 up to Bn is the digits of the second number. So A1 and B1 is added by the full adder with the carry. So first bit of first number, first bit of second number, A1 and B1 is added by the full adder with the carry input, carry from the previous digits. Maybe you can make it as carry C1 equal to 0. Now after adding, the sum is generated, S1, and carry also generated, that is given to the next parallel adder, next full adder, right? So this is the carry from the previous digit, and it will add second bit of first number and second bit of second number and carry. So it will generate the sum S2, then it will generate carry 3, that is given to the next full adder. Like that the carry will be forwarded. So every stage will get the sum S1, S2, Sn minus 1, Sn. Finally we have carry out, right? So full adder will add 2 bits and 1 carry. Is parallel adder means n number of full adders are available The digits are added, corresponding digits are added, and sum is generated and carry is forwarded to the next digit. Now we'll see the further details. So what we discussed, the description available as shown in the diagram. Firstly, the full adder FA1 adds A1 and B1 along with the carry C1 to generate the sum S1 and carry C2, which is connected to the next adder in chain. Next, the full adder FA2 uses this carry with carry bit C2 to add with the input A2 and B2 to generate the sum S2 and carry C3. So which is again further connected to the next adder and so on. So that this carry is forwarded. The process continues till the last full adder FAN uses the carry bit to add with the input AN and BN to generate the last bit of the output along with the carry bit Cout. Finally, it will generate the Cout. Right. So in this video, we discussed the parallel adder. How we are parallelly adding the numbers, 2-digit n bit of numbers. Normal full adder will add only 3 bits, 2 inputs and 1 carry. If you want to go add more than 1 bit number, mean we are using parallel adder. N number of bits mean n number of parallel adders are needed. Corresponding bits are added together and generate the sum and carry. Carry is forwarded to the next digit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.